Hello guys, in this video I would like to explain about the normality test. This is very common and when you are dealing with the statistical test, particularly I can give some example like when you are dealing with the regression analysis or hypothesis testing, and when you are working with the time series models like ARIMA models, AR, and moving average models. These models have assumption of normality that the data is normally distributed with a particular mean and standard deviation. So in that case, you need to test the data before embarking on modeling, time series modeling or regression modeling or hypothesis testing. You need to know about the conditions of the data, whether the data is normally distributed or not. For this purpose, various tests have been developed, and you can use any of them as maybe you know about that test, so you can use. In this video, I would like to explain about three tests, and the first one is um, Anderson-Darling test. The second is Shapiro-Wilk test, and the third one is Jog-Bira test. So you can go and you can see the literature about these tests. What is the purpose of this test? What is the null hypothesis? And because that is very important, you need to know about the null hypothesis. Otherwise, you will be unable to interpret your result at the end of the test. I mentioned the test, the null hypothesis for these tests. But if you want, you can go and you can see literature for further details. Okay, so let's move to Python, that how we can perform this test. And but before performing this test, you need to know details about each of these tests. That what is the null hypothesis, what is the alternative hypothesis, how we can interpret the results, and what is the test statistics, and you mean different information, and for purpose you can use these tests. That's important. Okay, so let's move toward Python. Yes, the first test that is the Anderson-Darling test. If you Google this test, you will see like this. Anderson null hypothesis in Anderson-Darling test. This is just my Google. You can see you can use the Anderson-Darling statistic to compare how well the data set fits different distribution. The null hypothesis is that the data are normally distributed. So you can Google for other tests as well. So this is null hypothesis that the data is normally distributed. So if we have a test statistic and the p-value is suppose 0.05, but in this case the comparison is different because you need to compare your values of the test statistic with the critical values. So let's do this, and then I will explain interpret the result at how we can compare the results in case of Anderson-Darling test. This is just a hypothetical data developed. You can do with your own data, of course. And I already explained how you can read data from CSV file, how you can read data from online sources. You can see my previous videos in this playlist, data analysis with Python. The link of this playlist is given in the description of this video. Okay, the first thing you need to do this from this states import Anderson. You need to import Anderson from this. Okay, this is important, and you can use for other as well, Shapiro here, and then Jogbira also from this. So you can use the same this C5 state, and you import Jogbira here, and you Shapiro and Anderson. So do this first, otherwise the command will not work. And then you just need to do this the data which just I have for just explaining these tests, and then you can apply Anderson-Darling test. This is the result we just save in the results. So Anderson-Darling test, Anderson bracket data is from here. Okay, so you can just take the test statistic from this because you need to compare the values for this test with the theoretical values, and the theoretical values are available at different level of confidence. Okay, just print the test statistic. The test statistic look like this. Just copy this because I have the p-value, the theoretical values. So that is statistic I can copy here because this is previously reported. This is the test statistic now. You can of course read until here to 3 or 4 values of course. And these are the theoretical values, remember. 15% in this one, 10% this one, and 5% this one, 2.5% this one, and 1% this one. Now this is the interpretation for the previous test statistics. So you don't need to now to read this one. You can just look at this. This value exceeded all these values. This value exceeded all these values. So this means that we reject the null hypothesis at 5% level and of course at this level also. At 5% level and 10 and 15, we reject the null hypothesis. The data is not normally distributed. So you can write like this: reject the null hypothesis 15 and 10, and still we reject the null hypothesis at k. Rejected this and rejected this as well at 5%. But we are unable to reject the null hypothesis at this and this because the statistic value is less than this value and this value. So at 2.5% we accept the null hypothesis that the data is normally distributed, and of course at 1% we accept the null hypothesis that data is normally distributed. I think this is interpretation. You need to have these values, theoretical values at this some specific level of significance, and then you can compare the value. You don't need to have this. You can just mention this, or maybe you can just write 9 here, just round up. So that's fine. You can compare and you can just conclude about by using Anderson-Darling test. We accept the null hypothesis at 2.5% level of significance, and then the data is normally distributed, and of course at 1% is not at this level. It is very close, by the way, but yeah, of course, still. So this is all about Anderson-Darling test, and now move toward Shapiro-Wilk test. I just mentioned here the Shapiro-Wilk test, the null hypothesis that the data is normally distributed, and of course here in Jogbira also have the same null hypothesis. The data is normally distributed, so that easily you need to know, you need to remember this because you will be unable to interpret your result if you don't know about these the null hypothesis. So now again, same from the same library you can import Shapiro. Okay, and now apply the same test Shapiro and to data. So just apply this command and data, and you will have test. Remember that I mentioned this was state, but I mentioned S for Shapiro, just for S, because I have the same thing state and p-value here. So for jog Bira, I just write J here with the state J and p-value J. Similarly, I wrote state S and state p-value S just for Shapiro-Wilk test S from the beginning. So this you will have test S and p-value S for Shapiro test. Just apply this. So you will have these two values, and now you need to print stat S, the value of stat S. This will just write like this test statistic, and this will mention the value of the test S from this result, and similarly p-value, and then the p-value S will be collected from here and will be printed again this p-value. Just click on this and you will see the result. Okay, so this is the result now. Test statistic is this one, and a p-value is 0.025. Okay, so this is obvious now that You can see this is close to the Anderson-Darling. That was, we accept that hypothesis at 2.5% level of significance. So this 0.025, this means that this is less than 0.05. So we accept the null hypothesis at 5% level of significance, and we can conclude that the data, no, we cannot accept the null hypothesis because the p-value is less than 0.05. This means that the p-value, this means that we reject the null hypothesis at 5% level of significance. Remember, p-value is less than 0.05, we reject the null hypothesis and we accept the other hypothesis. So p-value is less than 0.025, so mean that the data is not normally distributed. And now let's move to Jagpira test. Again, the null hypothesis is similar. And again, do the same thing, just import Jagpira. And now apply the test. And remember, I already explained state J and p-value J. That's just for Jagpira test, because there is another test, Shapiro-Wilk, that have also the same p-value and state. So I just, for differentiation, I mention S here and J here. Again, run this test. And again, run the same thing. Stat J means stat J value, statistic value from here, and p value J means p value will be collected from here. Just print this. So this is p value is a bit different, but yes, test statistic is this one, and the p value is 0.038. Still, it is less than 0.05, so we reject the hypothesis, and we can conclude that the data is not normally distributed. So all the three tests give identical result in this case at 5% level of significance. Just mention a value of 50, and you will see all the values at statistic and the p-values will be changed. Just this you can see just the sensitivity. Now you can just mention this, and you can see 3.52, and this was 0.729. So how huge the difference is. And now you can do this. Oh, this is no problem at all. The p-value is so less. Yes, minus 0.07, minus 0.07 raised power. Similarly, you can do this. Yeah, minus 2.41 power minus 39. You can just play with this data and, to see the sensitivity analysis of this test. Will give you at 3.25 again, because there are only 20 value to 20 observation is mentioned here. I just included another value of 20. So it's far away from the data. By the way, look at this. So it's far away from the data. 15 is closest, but remaining data is too far away. And similarly, the p-value is still yes. Yes, again, so you can decrease or increase, mention different values, and you can see the sensitivity analysis of these tests. So this is very important lecture for all those who are dealing with the regression analysis, hypothesis testing, and time series analysis, and maybe other field as well, because normality is an important assumption. So these are the tests you can use for normality. And by the way, this is numerically, these are the numerical tests. I will explain in the next lecture that how we can test graphically or whether our data is normally distributed or not. So you can see these two lectures together to have an holistic idea that how we can test our data normally distributed or not. And if you're presenting both numerical and graphical result, this will give you a very good message to the readers. Thank you very much, and see you in the next video. Ciao.